I love the graphic calculator once. Oh, Glasshark, he loved the fat kid. That's one thing about Glasshark you gotta know. He loved the fat kid. Don't go in the water, fat kid. Glasshark coming for you. What am I saying? If you don't know what that video is, then this is weird. This is awkward, huh? All right, graphing calculator. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of T, where T is measured in hours. This is a rate problem. Okay, so this is a rate. 0 to 8. Okay, well, seems familiar. At the beginning of the workday, T equals 0. Okay, great. The plant has 500 tons of unprocessed gravel. During the hours of operation, from 0 to 8, the plant processes gravel at a constant rate of 100 tons per hour. Okay. What does that mean? Oh, the unprocessed gravel is arriving, and then it's processing it at 100 tons per hour. So I feel like the unprocessed is like the inward rate, and then 100 tons per hour is the outward rate. Okay, so like maybe we minus to find the total like amount of unprocessed gravel, or the rate at which it's changing. You do this minus this. Maybe. Let's see. Part A. Find G prime. Using correct units, interpret your answer in the context of the problem. Okay, just take the derivative. Easy. And then I can use my calculator to plug in plug in is 5. So let's interpret the, I have to say the units, using correct units. Okay. What does G of T tell me? On a certain workday, the rate in tons per hour. So this is not tons per hour. At which unprocessed gravel, so this was a rate, and I'm taking the derivative, so it's how fast the rate is changing, or like the rate at which the rate is changing. At a gravel processing plant is modeled by this, where T is measured in hours. So this is, the normal units for this is tons per hour. So then the derivative, it's like the second derivative. It's like acceleration. It is acceleration. If this is the rate at which gravel is being processed, the derivative of this is the acceleration. Like if you had position and then velocity and then acceleration. So it's kind of like instead of like miles per second, that's fast. Well, maybe it's not. Or like meters per second, there would be meters per second squared for acceleration. This will be tons per hour squared. So let's say that. Or you could say tons per hour per hour. And now let's say in words what this means. And I think the easiest, remember, it's very important that you understand the language here. If we talk about the volume increasing or decreasing, then we're talking about the amount that comes in, right? If we're talking about the volume increasing or decreasing, we're talking about the amount, but it's changing. Or like if we say the volume is increasing, then that's saying the first derivative is positive, right? Well, here we're saying the derivative of the first derivative. So we can just say this, since it's negative, we can say G of T is decreasing at this rate because this is negative. Because if I'm saying G of T and I say decreasing, I'm actually talking about the derivative of G. And G of T means the rate at which gravel is processed, right? At which unprocessed gravel arrives at the... Oh, no. The rate at which gravel is processed is 100. So the rate at which unprocessed gravel arrives is... So right now, if I just said the rate at which unprocessed gravel arrives, I could say like positive or negative, but if I say is decreasing, that means I'm talking about the derivative of this. And decreasing by negative 24.588 tons per hour squared. And don't forget when T equals 5. That's important. So there you go. That's part A. Kind of simple if you just remember how to like write down the words. I guess that's for everything. Find the total amount of unprocessed gravel. Ooh. The total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So we have the rate at which unprocessed gravel arrives. To get the net amount, we would have to integrate. We get the antiderivative. And this one, hopefully, remember from the other day, it's just the integral from 0 to 8 of g of t, right? Is this positive the whole time? Oh, I didn't realize I had a recording. Whoops. Here's the thing. I looked at this, and this g of t is actually always positive because this can't be smaller than negative 45, and negative 45 is smaller than that. So g of t is always positive. So we can just take the integral of g of t. Because remember, the area underneath a rate curve gives you the net change in whatever we're talking about. So in this case, it would be the amount of unprocessed gravel, because we have the rate at which it arrives. Okay, so just do that in the calculator, and that's pretty easy. Don't forget your units, because they give you the units. That's part B. Oh, fancy that. Is the amount of unprocessed gravel at the part C. Is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? This is exactly like the problem that we did before. We do have to have the rate at which it's arriving and the rate at which it's leaving. We have to combine those. Well, if we're leaving this, we'll say minus 100. So is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? Show the work that leads to your answer. So C, for parte C, we have g of t, because that's the rate at which it arrives. So we can say 90 plus 45 cosine t squared minus 100, because it's a constant rate at which it's being processed. And it says, is this going to be increasing or decreasing? Or is the amount going to be increasing or decreasing? So that is telling us, if we're talking about the amount increasing or decreasing, we're actually talking about the derivative of the volume, which is given by this. This is the total rate of change of the amount that we have. And we just plug in 5. So this is the total rate at which the amount of gravel is changing, and if I plug in 5, I get negative 1.859235969. So this is negative, which means the amount of gravel is decreasing, because the rate at which it's changing is negative. Again, the wording, the sentence that you write is very important. The amount of gravel is decreasing at t equals 5 because the rate at which the amount is changing is less than 0, negative. There we go. Part C, done. Part D. Man, this question is like almost exactly like the problem that we did already. What is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? The maximum amount. So we need a formula for the amount, but luckily we kind of already got part of that. That's the amount that has arrived. So we can also just include that 100, the rate 100, so minus 100, right? And then I think that would work. We have to include the minus 100 in here. But also, remember, this is just the amount that is arriving minus the amount that's leaving. So that's fine, but we start out. We can't forget this. I think a lot of people would forget this. The plant starts out with 500 tons of unprocessed gravel. And that's just an amount. That's not a rate at all. So for part D, the integral that we'll be looking at, I'll just call it A for amount. The amount will be 500, because that's what it starts with, plus the integral from, and it says, what is the maximum amount of unprocessed gravel at the plant? So we want the actual function 0 to t, and it's g, so I have that minus 100 in there. That's the total amount, and maybe, oh, no, I got to change this, because I'm going to be using the fundamental theorem of calculus. I'll take the derivative, which is what I actually want. A prime, this would go away, and then I just have 90 plus 45 cosine of t squared over 18 minus 100. Remember, you just put that in there. That's why I changed the variable. So that's the amount, or actually the derivative. We want to set that, because to find maximums or minimums, you take the derivative, set it equal to 0, so that you can find the critical points. That's the turning points. And then any critical points that you have, you check the y values. So we'll need to plug in the critical points to this. That's why we needed this in the first place. So we'll plug in our critical points to that, and plug in our endpoints as well, and then see which one is the most, the maximum. So that's what I'm gonna do. I set it equal to 0, and then in my calculator I'm gonna find the critical points. So I'll just put that in my calculator and then solve for t. And t has to be between 0 and 8. So here we go. And I gotta check my endpoints. So a of 0, that will equal something. A of 4.92348, and also a of 8. And this, I'm just plugging in my calculator for t. So it's pretty easy, hopefully. Yeah. All right. And so I can do this integral part in my calculator. You could do that by hand, maybe? No, because of the t squared. All right. A of 0, that's just when I plug in 0 here. So the integral would be nothing. And we just have 500. And then we plug in 4.92. And we say, what's 4.92? So I had to do 500 plus this integral. Don't forget that 500. And it's 635 and change tons. And then we plug in 8 and we get 5 to 5.551089. So then our maximum definitely occurs when just before 5. So what is the question saying? What is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? So the maximum amount is 635 tons, and justify your answer. So why is this the maximum amount? Because the only relative extreme, the only relative extreme is when t equals 4.9 something, and when we plugged it into our original amount function, it gave us the highest. So it's not just a relative extreme, it's also an absolute extreme, and it's the maximum. And then we could say, so the relative extreme occurred at t equals 4.9, blah, 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 blah. And we showed that because we took the derivative and set it equal to 0 and solved. And the amount at that time, because I didn't want to write this again, the amount then is larger than the amount at t equals 0 and t equals 8. So that's the justification. And this video is too long and I'm going to be gone. Good night. Good day. Good morning.